It's a beautiful Monday morning, or maybe not so much morning. It's 10:30. I just made a coffee, and today marks the beginning of the fourth day of um, etcd source code exploration. And after these days, this diagram, this sketch that you are seeing, which you cannot see very clearly. Now you can see very clearly. This sketch, this very initial diagram, was made yesterday, and this highlights my current understanding of etcd. What I'm trying to highlight in this diagram is more of a mix of different layers. So etcd, the etcd server, has multiple, let's say, I wouldn't say responsibilities. I would say rather it has multiple concerns, or it has multiple layers of concerns. It has the API layer. It has the part that concerns clusters. It also employs the Raft library, which itself implements a Raft cluster, but etcd also has a cluster on top of that, because it has to, let's say, couple together. It has to tie together the logic from the Raft with something that makes etcd useful. For instance, Raft doesn't have any persistent storage. It only has in-memory storage, and it simply implements the Raft consensus without other assumptions. Those assumptions are tied together, are implemented by etcd itself. So that's why etcd itself also has to have a cluster, or the concept of a cluster. Then etcd also has persistent storage. There are 3 types of persistent storage, each of which comes useful at a different time. Then also etcd server also has in-memory storage for quick retrieval, for quick access, which will eventually be flushed into the persistent storage. etcd also has MVCC, which stands for multi-version concurrency control. This essentially means that besides being a distributed key value store, etcd also implements a behavior for versioned key value stores, for version key values, meaning that you get to, just a simple example, if you have a request from a client to set x equals foo, then that is the version 1. But you might also get updates on x, maybe x equals bar, and that is a new version of x. But etcd will also keep, for a while, will also keep the previous version from different reasons. I don't know exactly why. I suppose it has to do with the way it works together with Kubernetes and the Kubernetes needs, but I'll have to figure it out later on. And lastly, etcd also has, I have mentioned these two here because I don't know exactly where to put them. I have understood that etcd also is the one that, or the etcd server also has a state machine on which it applies commands from the client, but I don't know exactly where it is. I've heard that it exists, but I couldn't see it yet. etcd also has the concept of a lease, which to my understanding is used to implement a distributed locking, which I haven't yet got the chance to explore. So these two are things that stood up, that seemed very interesting, but I couldn't actually understand what they are, or I couldn't actually understand where they are in the code. So this is my current status. I say I've got pretty far. I I'll keep updating this diagram in a way that it eventually makes sense. One last thing that it might not be very easy to see is the fact that BoltDB has this small annotation which says go run. This is because one very nice thing about etcd server is that it spawns multiple never-ending loops in Go routines, and each Go routine is responsible for a certain area, and these Go routines communicate with each other via channels, and that's very interesting. I personally I come from the JavaScript land, where this is not very common. It might be common in Rust, which I've got the chance to learn, but I haven't got so deep into that. But now I see how things are really done at an important scale, which seems to be etcd at. And the basic idea about BoltDB, because this is the first one, or this is the only one that I got the chance to really understand, BoltDB is essentially it's a database in itself. It's an embedded database, which means that it can be simply imported in your program, and now you have a database. It's basically a simple B+3 that can be used for storage. This comes with advantages and disadvantages and so on, but it's a different topic. Anyway, in the end, the persistent storage will the persistent storage of etcd, which might imply stuff like authentication data as well, data that concerns the state machine, I suppose. All of them will end up in BoltDB. And basically this loop is responsible for actually committing the accumulated data into the persistent storage. I don't think I'm able to say much more, or I don't think I'm able to say more about this right now, about how this loop works, because it needs some concepts from other parts as well. So I think I'm going to end now. This is my current state of understanding of etcd. For some reason, laying out things like this makes sense for me, but I'm not sure if it would make sense for anyone else. But anyway, I will use this diagram. I will update this diagram in order to deepen my understanding, and in the end, I will be able to make more more diagrams that are more understandable. So this is my current state. I'll see where this journey takes me. Thank you for watching, and I'll see you in the next one.